So I'm not going to talk about energy in general, but I'm going to focus on the electric power system. So that is the role of my profile in the area of advanced energy. And if you look on the electrical power system, we are so used to have electricity at home that we don't think that the electrical power system is very new. It is only about more than 100 years ago that the electrical power system was established as a first step on what we know today. And it was used to demonstrate it was possible to transport electrical energy over long distances. That was in these exhibitions that you had in Frankfurt. And since then, the electric power system has evolved in tremendous speed. So you start from here, where you have Thomas Edison that has been inventing the light bulb, down to the electrical transmission system on the power system that we have today, with the classical structure that we have with the transmission network, the distribution network, and the loads. The question is, how will it look like tomorrow? We have seen a lot of very nice ideas, starting from the desert tech idea to these supergrids that should involve the complete globe. And a lot of people think, okay, this is too much. I mean, it's too futuristic. It will never happen. And the question is, really? Will it ever happen or not? For those of you that are familiar with Northern Europe, here you see a drawing of Sweden, Germany, and Denmark. And in 1909, there was a first proposal from Vattenfall saying we should have a DC transmission between Trollhättan and either Berlin or Hamburg. It's great. We are going to transport a lot of electricity, a lot of electrical power. And at that time, this idea was flanked because they thought it's too much energy. No one will ever use so much energy in the world. And do you know how much energy it was? It was 50 megawatt, more or less the energy that we consume in this building now. At that time, it was too much. So if you compare this with what is going on today in China, for example, okay, maybe I'm Italian, but here I see a lot of spaghetti on that drawing there. And basically, these are just new projects, where here we talk about terawatt. So this is amazing. The basic idea is that, okay, we should not just close your eyes and think this is too futuristic. We should think about, okay, what do we need today? And what we need is basically, from an electrical power system point of view, to integrate renewable energy sources. That is where the European Union is going, where more or less all countries are going. And what the ambition that we have in Sweden is a bit more strict than what we have in general in Europe. Here we want to have 100% fossil-free renewable energy sources by 2045. And this should be replacing all the non-fossil-free generation. And then the type of fundamental changes that we must have, of course, is renewable integration, but we have also other questions about energy storage, and then that is where it comes, digitalization in the electric power system. There are studies that show that already today we can expect that if we don't do anything with our power system, then we are going to miss about 7 gigawatt of electrical power, especially during cold winter times. This is a prognosis that is made by Vattenfall, but I mean, other studies have shown the same. So we know that the power system must change in order to avoid such situations. On the other hand, what we know also is that the technology when it comes to communication is increasing at the speed of light. When I bought my first iPhone, it was a 3G iPhone. It was fantastic. I thought, wow, this is flying. Then the 4G came, and then I thought, okay, now I'm flying. And the next one will be the 5G. And then we will see what happens. If you think that you will move from 100 milliseconds latency that you have for a 3G down to 1 millisecond, then you will understand that it is possible really to control devices, to control the power system, even from the cloud. It will be very interesting to hear Ericsson later to talk about this. So if you look now on the evolution that we had, at least in Sweden, but it's more or less the same all around the world, you can see that if you, okay, it's difficult to read maybe, but on the green part, you have the evolution that you have from a digital sector, and then you have the evolution that you have in the electrical sector in the red one. And you see that they more or less start at the same time. The digital sector started in 1883. If you look at the electrical sector, is 1885, so it's quite similar. But then they've always been going through parallel lines. Now is the time when they start to merge, where the two technologies start to go together. And here is just a quick list of the different challenges that we have at least identified here in Sweden. Sorry, at Chalmers. But the question is, of course, how would the electrical power system change? Well, if you ask me personally, then for me, this is the electrical power system of the future, which simply means I have no idea. Honestly, I mean, you can see the most crazy ideas in the world, but I mean, how it will look like really in the future, we don't know. The only thing that we will know is that it will be a lot of renewables, it will be a lot of energy storage, it will be a lot of data. And these are some of the trends that we see in the future. Here is just a summary of what we are doing in our profile here at Chalmers. So what we are really working on is this one. It's not about the future. The future we don't know. We are working on the transition. How are we getting there? And what are the tools that we need to get there? And here is just a quick list of the type of projects that we run that go mainly from electric power engineering to system to IT and others. Yeah, thank you.
Thank you, Massimo.